will be Geometry Lesson 8.7. Today we'll be discussing two different concepts that go with circles. We'll be talking about area and circumference of circles. What circumference is we'll talk about here in a little bit, but that's more or less perimeter for a circle. So here's all our definitions. A circle is a set of all points the same distance away from a given point, so that's the center. So if this is the center of our circle, every point on this circle is the same distance away from that center. So, if the distance from C to B is 6, the distance from C to A 6, C to D 6, anywhere along there would be 6. Okay, so that's the definition of a circle. The diameter is the distance across a circle through the center. That's important, through the center, because this is not actually a diameter. That's something else that we'll talk about at the end of the semester. But the diameter has to go through the center. Now that's the longest distance across a circle. The line or the segment I just had drawn is actually shorter than every segment in there, except when it goes through the center is shorter than that diameter. Now the radius is simply the distance from the center to a point on the circle. The radius is half the diameter. The diameter is twice the radius. So again, if this is the radius, if that's 5, the whole diameter here would be 10, and vice versa. Right? The circumference is the distance around a circle. This is the perimeter for circles, except perimeter we talk about being the sum of all the sides of a polygon. We don't have any sides for a circle, so we call that circumference. Again, I always think this, if this is a dog on his leash, he's staked down here, those dogs always wear a circle out. That distance, that circumference, is the distance that dog walked around that circle. Right? Now, a central angle, we have one drawn over here, and a central angle is exactly what it sounds like. A central angle is an angle who's at the center of a circle. So this angle right here, BCD, would be an example of a central angle. Well, you're thinking, well, what else? What other kind of angles on there? Well, if we look at this, if I drew this and this would be another angle that's actually part of the circle, but it's not at the center of the circle. This is an inscribed angle. Again, that's something we'll talk about later, but that is not a central angle. It's not at the center. Here's a central angle. Here's another central angle. Here's another central angle. That's a 180-degree central angle. So what we have is central angle, angles at the vertex. Now, a sector. A sector is kind of like a piece of pizza, if you think of it that way. It is a region or an area of a circle determined by two radii. So we have two radii and the part of the circle. So if we look at this, C to B is a radius. C to D is a radius. The sector is that part of the circle, is this whole part of the circle. Now what we can do is we can actually calculate the area of that sector as well after today. Right, so we'll actually be able to find the area of that piece of pizza. Right? So let's go do some calculations now. Find the area and the circumference of the following circles. Give answers in terms of pi. That's kind of a new thing for us, and I will show you that. That's actually the easiest way to do that. And round it to the nearest tenth. The thing about rounding to the nearest tenth is we need a calculator, and then we round, and it's not exact. Okay, so let's go find the area. By the way, if you look up here, here are the two formulas for today. The formula for circumference is 2 times pi times the radius. And the formula for the area of a circle is pi times the radius squared. Right. So let's go ahead and jot those two formulas down. We'll go area first. Area is simply pi times the radius squared. So when we do the math on this, we take pi, which again you probably know is 3.14, 3.14159265395 all that good stuff. Pi times the radius is 5 squared. Now, here's one answer. We take 5 squared, we have 25, that's nice and easy, times pi. Done! This is an answer what we would call in terms of pi, 25 pi. Now my label, this is area, centimeters squared. Right? Now, that is a great answer right there. The reason I liked that one, I didn't need a calculator, and I didn't have to round. Now, if we did round this to the nearest tenth, if you took 25 times pi, you would get 78.5 centimeters squared. Now, what I had to use a calculator for that. I couldn't do that in my head. Let's go to circumference. Okay, for circumference then. Circumference, the formula is 2 pi r. Pi r squared, 2 pi r. Easy way to remember this. When you do area calculations, the unit is labeled squared. When you do circumference, it is a distance. It is just units. There is no square here. Common mistake here. I see 2 pi r squared. No. Get these formulas down. Alright, so what we do here, the circumference is 2 pi r. My radius is simply 5. So we take 2 times 5, which is 10. So my circumference is 10 pi, label centimeters. Okay, that is in terms of pi. These two answers, terms of pi. That's great. We didn't have to round. We didn't even have to use a calculator. But now if we want to use this calculator and we want to do it to the nearest tenth, we can take 10 times pi and you get 31.4 centimeters. Centimeters. Circumference is like perimeter. It's not units squared. It's just units. All right, let's go to number 2. Same process here. So the area is pi r squared. The radius is 10 squared. So my area is 100 pi. So that is our area, 100 pi, label inches squared. Again, what we can do now is we can take that times 100 and we get 314.2 inches. Just inches. No squared on that one. Or yeah, that's inches squared, sorry. Alright, so let's go to circumference. Same process here. Circumference is 2 pi r. In this case, my radius is 10. So we're going to take 2 times pi times 10. 2 times 10 is 20. 20 pi. So that is my circumference, exactly 20 pi. We didn't even have to use a calculator for that, 20 pi inches. Now, if we do want to use a calculator for that, that would be 62.8 inches. Right. So we have 4 different answers here. We have our exact in terms of pi answers for area and circumference, and then we have our approximate. And I'm going to want those today, both of them. All right. Now, if you notice this, guys, here's another formula for circumference that some math teachers will teach you. If you notice what the area or the circumference was here, it was just twice the radius. Well, what does that give you when you do twice the radius? That gives you the diameter of 20. Well, here's another formula for circumference. It's just pi times diameter. Now, you don't have to remember that one. I just always use 2 pi r. That way you're always stuck with the radius. All right, next ones. I'm going to go ahead and hop down to number 6. You can go back and backtrack and do 4. Actually, let's do 4. When we do this, we have the formula for area is pi r squared. Well, we have to look because I gave you the whole diameter. The diameter is 30. The radius would be 15. So we simply do pi times 15 squared. And that is 225 pi square feet. Okay, so that's our calculation for the area of this guy. The area would be 225 pi square feet. And then we could go ahead and throw that in our calculator, 225 pi, and give me an approximation, 706.9. Approximately 706.9 square feet. Now that's why we don't want to that's why we don't want it rounded sometimes, because then we got to round, and once we round, if we use this number, it's going to affect our final answer as well. And the more you round, the more you're off at the end. We'll see that in chapter 9. All right, let's go to the circumference. So the circumference is 2 times pi times the radius. Remember, I just gave you that one pi times diameter as well. So the circumference will be 2 times pi. The radius is 15. Well, look what that takes you right back to. 30 pi. So there's our circumference. 30 pi just feet. And again, if you want to go ahead and give me to the nearest tenth, you take 30 times pi, and you get 94.2. 94.2 feet. Again, what I should have done, squiggles. Approximately 94.2 feet because we had to round. Right. Same process on 16. You can do that one. That would be 11. And I worked these two for you on number 6 already, that you should have gotten 380, approximately 100, or exactly 121 pi inches squared, approximately 380.1 inches squared. For circumference, you should have a circumference of 22 pi inches, which is approximately 69.1 inches. All right, now, if you look at 7 and 8, let's look at 7 and 8. There should be a fraction that pops into your head right now. This is no longer a circle. What we call this is a semicircle. Okay, a semicircle is simply when you cut a circle in half through the diameter. So you cut it right along the diameter. That's a semicircle. Right? Now, what fraction pops into your head right here? I'm hoping 1/2 does. All right. So what we're going to do is we're going to do all the same calculations here, except we're going to go ahead and cut it in half at the very end. So you go ahead and work number 7. I'll do it, and then I'll give you the answer. So you go ahead and work it. I'm going to pause the video, and we'll come. So what I did is I set it up my formula, area equals pi r squared, but then I included this 1/2 at the very front of this guy. So what I did is I did pi r squared, pi times 6 squared is my radius, and then I did pi times 6 squared, well 6 squared is 36. Now what I'm going to do to keep this in terms of pi, I'm just going to take half of that 36. Half of 36 is 18 pi. So my final answer is simply 18 pi meters squared. And then you can go ahead and take 18 times pi and get the approximation for that, which is 56.5, approximately 56.5 meters squared. Circumference, we will work the same way. Circumference, now circumference, we're going to be half of that as well, so I'm going to include the 1/2 times 2 pi r. We do 1/2 times 2 times pi times 6. That's 1/2. 2 times 6 is 12, so we have 12 pi. So well, half of 12 is 6 pi. So my circumference approximately is going to be 6 pi meters. Well, if we take 6 times pi, I'm about approximately 18.8. So approximately 18.8 meters. Now the trick to this one is we could actually, if we wanted to, we could include the diameter. Depends on if we are. If I just want to find, hey, what's the circumference of the semicircle, I just took half of it, I'm done. But we could include this 12 right here if we wanted to, depending upon the situation. Right now, I'm not going to. Okay. So I'm going to work number 8 right now. I'm going to pause it. You work number 8, and then we'll come back and we'll see if we get the same. Okay, so the area I got, now remember you had to take half of that 14 and get 7. So that was the radius that we needed to use, and hopefully that's not a mistake you made there. Don't use that 14, that's the diameter. The radius would be 7. We took 1/2 pi times radius squared. Pi r squared is 49 pi, and then I took half of that 49. Well, half of 49 is 24.5 inches squared, and rounded to approximately 77 inches squared. Circumference, same process. We took 2 pi r, half of that. 2 pi, the radius was 7. 2 times 7 gives me 14 pi. Well, half of 14 pi is 7 pi, so that was our circumference. Alright, the next problems, here we go. I'm going to give you these work backward problems. The area of a circle is 25 pi centimeters squared. Oh, baby. So we have the area of a circle, so we might as well, step 1, write the formula down. Pi r squared. Step 2, substitute in what you know. The area is 25 pi. We need to be careful that we have 25 pi, not 25, 25 pi. Pi times the radius squared. Well, look what we have. Once we substitute in for the area, we only have one variable, and we can solve for that one variable. So what we need to do is we need to get rid of pi first, and then we can get rid of that squared. So we're going to divide both sides by pi. So I can get rid of that pi. Divide this side by pi, divide that side by pi. Well, what happens, pi divided by pi is gone, and so is that. So what we are left with now is 25 equals radius squared. And if you don't know how to solve this, you've kind of been asleep for the last couple of months, because we've done this at the end of every Pythagorean theorem problem that we've done. How do you get rid of the squared? Square root it. Square root. So the radius is the square root of 25, which is 5. Now that's step 3, is substitute, simplify, and solve. Step 4 is label. Okay, well, what's the label here? Centimeters squared was my label area, so the radius is going to be 5 centimeters long. Okay, so my radius is 5 centimeters. Now, I also ask you, what's the diameter then? The radius is 5 centimeters, the diameter is 10 centimeters. Okay. Now, number 9 and number 10 set up very similar, but solve slightly different, because if you look at number 9, my area was 25 pi. I don't have that over here. This one, it just says, hey, the The first thing we need to do here at number 10, again, we're going to write our formula down. The area of a circle is pi r squared. Now we're going to substitute in what we know, and this is where it becomes a little bit different. Over here it was 25 pi. Right here it's just 452.39 equals pi r squared. There is no pi here. There is no pi to cancel out with here. But we do need to get rid of pi over here. So we're going to do that same step and divide by pi. And we're going to do it over here. But over here there's that pi to cancel out with. Pi divided by pi cancels out. That's not true over here. So what you need to do here is you need to literally take 452.39 and divide it by pi in your calculator, and you get the number 144.00002. So I'm just going to put that as 144 equals, what's left over here, those pi's cancel out, r squared. Remember, step 3 is simplify and solve. So if we look at this, now we can solve it. We square root. So the radius is the square root of 144, which is 12. Step 4, label it. So up here, my label is meters squared for area. So my label for the radius would be 12 meters. So my radius is 12 meters, and that means my diameter is simply 24. Double that, 24 meters. All right, let's do the same types of thing, except this time we're going to look at circumference. And again, notice the difference here. 24 pi and 37.7, no pi. Okay, so the circumference of a circle, so step 1, let's go ahead and jot our circumference formula down. C equals 2 pi r. Right? Let's substitute in what we do know. We know the circumference is 24 pi. That's the biggest mistake on the test, is people always forget the pi. I'm a fat kid at heart, so I never forget the pi. So we have 24 pi equals 2 pi r. Now notice what we have over here is we have 2 times pi. I'm going to get rid of both of those. That's all multiplication. Well, how do you undo multiplication? We're going to divide. Well, darn it, let's just do both of them at the same time. I'm going to divide this side by both of those at the same time. And then what happens here? Pi's cancel out. 2's cancel out. Exactly what we wanted to, because now we're left with r. Over here, pi's cancel out. So if we look at this then, what we have over here is 24 divided by 2, which is 12. And what we have over here is r. So r simply equals 12. Label, step 4, label centimeters. So the radius is 12 centimeters. And the diameter is 24 centimeters. Right? Let's do this one. This one works kind of the same but slightly different. So again, the circumference of a circle is 37.7 inches. So let's go ahead and write the formula down. Circumference equals 2 pi r. 2. Let's throw in the circumference. The circumference is 37.7. Now notice, no pi. There's no pi there, so you can't make up a pi there. Equals 2 pi r. Now, here's something on a problem like this. This one, pi's canceled out, beautiful. What I think is the easiest way for you to do this one is to rewrite it. Because there's no pi to cancel out over here, if you literally take 2 times pi, like you put 2 times pi in your calculator, you get a number of 6.28. I always think that number is easy to remember because that's some of our prefixes on some of our phone numbers here. 628, 625, 623, all that good stuff. Now what we can do is we can take that. That's a multiplication. We can get rid of that times 6.28 by simply dividing by 6.28. Now, you could do this in your calculator. You could do this by dividing by 2 and dividing by pi. I just like to do it all at once. So I take 37.7, divide that by 6.28, and your answer is going to be 6. So the radius is 6. And our label is inches, so it's still inches here. So our radius is 6 inches. My diameter would be 12 inches. Right? Again, here we go. We're going to look at parts of a circle. We talked about these sectors at the beginning. All a sector is, if you can think of a piece of pizza, you cut a piece of pizza up, it looks like that. Now, it's got a nice rounded edge, and it comes to a point at the center of that circle. Now, remember, that center of that pizza, that's the best part of the pizza anyway, right here. So if we look at this, to find the area of a sector, this is another formula that you will be required to remember, and this to me is the hardest one. To find the area of that sector, what we are going to do is we are going to take the central angle. I'm going to label that as CA, central angle. We are going to divide that by 360. Now, why 360? Where's 360 come from? This central angle is 90 degrees, but how many degrees are there total? 360, that's right, times pi r squared. Well, where's that pi r squared come from? That's the area formula for a circle. Alright, so if we look at this, now once we have the formula down, really easy to use, we're going to take 90 over 360. We're going to take that times the area, which is pi times my radius, which is 8 squared. Now what I'm going to do real quick, you can take this expression right here, and you can throw that thing in your calculator. You can put 90 over 360 in your calculator as a fraction, and then just take times pi times 64 times 8 squared, whichever way you do it. So you can put this directly in your calculator. What I'm going to do is I'm going to simplify this because I want to show you why this works the way it does. If you come up to this circle and you just look, and you're looking at this guy right here, and you start thinking, oh, that's 90 degrees right there. What fraction of that circle are we looking at right there? Some of you might get that right away. To me, that looks pretty obvious. That's 1/4 of that circle. You divide that circle up there with the 90s, that's 1/4, 2/4, 3/4, 4/4, okay? What does this fraction simplify to? That fraction simplifies to 1/4 of, if you guys remember what of means from algebra, of means times the area of a circle. Okay, so we are taking 1/4 of the area of that circle. Well, now what we can do is we can throw this in our calculator. We can take 1/4 times pi times 64, and you get an area of that sector that is approximately 50.3 meters squared. Now, could we do that in terms of pi? You betcha, we could. Am I going to make you do that? No. When we do areas of the sector, we're just going to go straight to that decimal. Makes it a little bit easier on us because sometimes we get ugly, ugly fractions. Alright, so let's go to number 14. We're going to do the same process here. We have the area of a circle, the central angle over 360 times pi times my radius squared. Let's substitute in. The central angle that we are looking at here is 120 degrees. So we have 120 out of 360 times pi times my radius, which is 10 squared. Okay, what I'm going to do now, again, you can take this right here. Go throw in your calculator, 120 over 360 times pi times 10 squared. What I'm going to do is I'm going to simplify this. This fraction simplifies all the way down to 1/3 times pi times 10 squared. So what we are calculating here is we are calculating 1/3 of the circle because this area contains 1/3 of the circle. Okay, now what we can do is just throw this in your calculator. So 1/3, or you could do the 120 over 360 times pi times 10 squared, and you get an approximate answer of 104.7. Label, it's still a calculation of area, so it's still inches squared. So we have 104.7 inches squared. Alright, now I'm going to pause this. I'm going to go ahead and do number 15 right here for you, and you can go ahead and do it on your own, and then you can check your answer when you're done. Okay, so what I did is I set it up as the area is 240 over 360 times pi times 4 squared. And then what I did is I went ahead and simplified that. Remember, you can take this thing right here and throw it in your calculator as is, and you would get the same answer. I simplified that to show you that we found 2/3 of the area of the circle. So I threw that in my calculator. I got approximately 33.5 centimeters squared. Now I'm going to skip over 16, and I want to go to number 17. Find the area of the shaded region within the rectangles. Sorry for my spell check there. You will have to subtract the circles. Okay. So what we have here is we have two shapes. We have a rectangle with a circle cut out of it, and we want to find the area of what's left when we cut that circle out. So what we're going to do is we're going to set it up nice and neat. We're going to go to area of the rectangle equals, remember that's base times height. Area of the circle, which we just did, is pi r squared. We need to calculate both of these. For the rectangle, the base is 10. The height is 4, which is 40. So for the area of the rectangle, we have 40 inches squared. Now for the circle, let's start thinking here. All the way across here is 4 inches, right? So what's the radius of that guy? Now I know all the way across there is 4 because it's all the way across is 4. The radius would be 2, so when you set up the calculations here, it'd be pi times 2 squared. That's 4 pi. Now that doesn't help me over here because I don't have a pi, so what I'm going to do is I'm going to go ahead and take 4 times pi and give me an answer of 12.56, so 12.6 approximately 12.6 inches squared. Now what we want to do is we want to find the area of that rectangle that's not shaded, that's not part of that circle. So what we need to do is we need to cut out that circle. Now what that means is I'm going to take the area of the rectangle and cut out the area of the circle. I'm just going to subtract these two values. So I'm going to go 40 minus 12.6. So I'm going to take the area of the rectangle 40 minus that 12.6, and I'm going to get an approximate value of 27.4 inches squared. Alright, now let's go ahead and work on 17b here, and what we're going to look at here is that we have a semicircle, half of a circle cut out of this rectangle. So we're going to set it up the same way. We show the area of the rectangle, base times height, or length times width, however you want to look at it, 12 times 6, which has an area of 72 square feet. Okay, so that's the whole thing there. Now what we need to do is cut out that semicircle, so we're going to look at the area of the semicircle. Remember, when we have a semicircle, it's half of a circle, so we're going to calculate half of the area, which would be pi times radius squared. Right? So we go 1/2 times pi times my radius. Now remember, the radius, the whole side is 6, so the radius is going to be the 3, pi times 3 squared. Now that is, we're going to go ahead and throw that directly into our calculator, 4.5. We'll simplify a little bit. We'll be 1/2 times 9 pi, which is 4.5 pi. So I'm going to go 0.5 times 9 times pi and get an area of 14.1, approximately 14.1 square feet. Again, to find the area of what's left here, we're going to take the 72 minus the 14.1, and you get an area of 57.9. So the area that's left, the area that's shaded, is approximately because we rounded here, 57.9 square feet. Right. So that's it for that. You can work on lesson 8.7 now. If you do have any questions, make sure you come in before or after school or during seminar for help. Good luck and thank you.